Today we will start in the chapter 4. In chapter 4, we will deal with about some analysis technique for the electric circuit. Here we will do this two techniques is node equation and mesh equation. I already told you about how to analyze the electric circuit. What is analysis electric circuit means? There are many elements to consisting of the electric circuit. Something like that. That when you say we analyze this electric circuit means we can define the all voltage of this element and can define the all current flowing through each element. Then when you can identify the value of the voltages of all elements and the current flowing through all elements, then you can say, I know this electric circuit, and we can analyze this electric circuit. So to do that, we can use only two laws, that is KCL and KVL. So that's all. There is only two laws to govern this electric circuit. Based on this law, KCL and KVL, we can solve all kind of electric circuit. That's all. That is all. But from already we covered the two laws, KCL and KVL. So that's the things. But to analyze this electric circuit, we need some tips or techniques to solve the electric circuit more easily. There are several tips to do that. They will be covered from in chapter 4 and chapter 5. The most important popular technique is node equation, mesh equation. So I already told you that how to solve this circuit. The first, define voltage and current of each element. Second, simplify electric circuit. And third, make equations to solve the circuit. That's a simple things. And the second thing is also simple. I already told you about how to simplify the register in the case of register is connected in parallel and series way. Then this chapter we will do about how to make equations to solve the circuit. The technique to make equations is node equation and mesh equation. There's a kind of methodology to solve electric circuit. Based on these equations, we can solve the voltage and current based on the simple equations. The first technique is node equation. Today we'll do about the node equation. First, I want to introduce about what is node. The node is here. That is a node. The definition of a node is the place where the elements are connected. That is a node. There are three nodes here. This and here. So, and you see there are 4 elements. Element 1, and element 2, element 3, element 4. And this element, this and this and this is connected through this point. So we call this is a node. And this element and this element is connected here. So we call this place is node. And this element and this element and this element is connected through this place. So we call this is a node. So in this circuit, there are 3 nodes. So this is a 3-node circuit. So when you have a node, for example, you have n node, 1 or 2, in this case, n is 3. In this case, n is 3. That means you can have n-1 KCL equations. In this case, you can have 2 KCL equation. Why not an equation but n-1 equation? Because of independence. I'll tell you about that. And when you make a node equation, you should define the reference node at first. So it means node at the KCL is not applied. In general, bottom node or ground node, we call this a reference. So because of that, when you have n node, then you will have n-1 KCL equations, because one node should be used as the reference node. Generally, we can define the reference node as the bottom node, like B, or the ground node. Then I will tell you about what is a node voltage. So node voltage is a voltage at any node of the circuit relative to the reference node. This is very important. When you define the reference node, that is on your choice. So you can choose anywhere, any node as a reference node. But we recommend to choose the ground node as a reference node or bottom node as a reference node. That is easy to make a node equations. So in this case, if node B is a reference node, then we define this reference node then you can say that node there are, except to B, there are 2 nodes A and C. Then we can define the voltage A, VA. VA is a node voltage. That means the voltage difference from B to A, that is a node voltage. And there are node C, so we can define the node voltage here. We say this is VC. That means voltage difference between C and B. That means voltage difference based on the node B to the node C. And we call that is a node voltage. So we can make another example about that. For example, we can draw more complicated circuit here. It looks more complicated, but it's not important. Here, then there is a ground here. Then how many nodes are there? We can count it. 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 nodes. There are 9 nodes. 9 nodes. Therefore, we can make 9 minus 1 node equation. So based on that, we can calculate the voltage and current of each element. Then we can define, we call this A, B, C, D, E, F, G, H, I. We can define the voltage node, and node is A and from A to I. Then we define that is a ground, so I will choose that is a node, reference node. But it's depending on, you can choose H is a reference node. It depending on you, but in this case, I choose the first node as G. Then, what is the node voltage? And the node voltage here is VA is the node voltage of node A. That means from here to there, that is a VA. And what is node voltage D? And that is node voltage here, from G to D. And what is node voltage B? That means node from G to B. That is a node voltage between 2 points, B from G. And what is node voltage E? E from here to there. That is node voltage E. What is node voltage C? From G to C, we can say this is VC. That is a node voltage C. And node voltage F is from G to F. That is node voltage VF. And this is node voltage H. And this is node voltage I. So we can define the node voltage A is voltage difference, the specific node from the reference node as you choose. That is a node voltage. Then I will introduce about node equation. I told you that the node equation based on the KCL. So that is based on the KCL, but the equation is a kind of standard method or technique for analyzing a electric circuit as an unknown variable in the node equation. That means unknown variable in node equation is node voltage here. So electric circuit, the node voltage is a kind of unknown variables. And to calculate the simple equations based on the node equation, we can gather the unknown variable. That means node voltage base. So from there we can choose anything about the data here. I mean, we only told you that if we have n node, then there are n minus 1 KCL equations, because n node is one node is the reference node, so there are n minus 1 node. So that based on the n minus 1 node, we can make KCL equations from each node. So we get n minus 1 equations. And how many variables we have? When you have n node, and among that, one node is a reference node, so n minus 1 node is a node voltage. That means we have unknown variable is n minus 1 unknown variable. And we have n minus 1 equations from KCL. we have n minus 1 variables and we have n minus 1 equations, then we can solve these conditions. There is a way how to make the equations from the electric circuit. That is a node equation. So how to make a node equation technique? The first, express element current as a function of node voltage, because what is a KCL? What is a KCL? We have one node A, then there are many branches, then we can define the current IM, then sum of current is 0. That is KCL. So KCL is a function of current. And you choose the unknown variable as a voltages. So to apply the KCL, because KCL is a function of current, we should define all branch current as a node voltage. That is a fundamental key to make a node voltage here. Because KCL is a function of the current, so you should make a current as a node voltage and apply the KCL at each node for the reference node. Then you should know how to express the element current as the function of node voltage. That's very simple. There are two nodes here. This is node 1 and node 2. Then this is a ground reference node. The node voltage is V1. That is means the voltage from here to here. And V2 is the voltage from here to here. Then we want to know this voltage difference from here to here. What's the meaning of that? The voltage difference here means from here minus that. So node voltage here is V1 minus V2. When you define this is plus and minus. That's node voltage. In the same way, the Vs, this is a voltage source, but we call this is a node 1 and node 2. Then voltage difference between here is V1 and voltage difference from here to here is V2. So voltage difference between 2 points is V1 minus V2. That should be V2, Vs, because it's voltage source. Then if there's an R register here, then we know that is node V1 is node to V2, and we can calculate voltage difference from here is V1 minus V2. So then current, because we define the plus here and minus here, based on the Ohm's law, the current I is voltage divided by resistor R. So that is a way how to make the current as a function of the voltage node. That is expressed by the node voltage V1, V2. We can use this way to make KCL equations. Okay, this is an example to make a node equation. The first, I want to make the node. There are no three nodes, A and B and C. Now this is 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 a current source. And then first, what should we do? We should define the voltage of node. So I will define the voltage here. That is a VA. This is node A, is node voltage. And this is VB. VC, we say. This is VC. Then I will check the current here. This is I2. I'm sorry. This is not 2. This is I1. And this is I2. And this is I3. And maybe this will be VC. right? Then this is IS because this current source here. So we can make the current is a function of node voltage. So because this is IA, this is VA, this voltage is VC, then current from IA, I1, then voltage difference from the here and here will plus minus, here is this because this is VA and VC, so this is VA minus VC. Okay. Then you can make element current. Then I1, what is I1? I1 is V over R, and what is V is VA minus VC, and R is R1. And what is I2? I2 is current here. Then resistor is R2, and the voltage difference from this terminal to terminal is VA. So I2 is R2, VA over R2. And I3 is I3 VC, because we defined the VC here. So as you see, I1 is a function of V and VC. I2 is a function of VA, and I3 is a function of VC. So all current can be expressed by the node voltage VA and VC. So I told you that because there are three node, so two node voltage, and because there are two node voltage, there are two node equations. Now first, we define the current element with two node voltages, VA and VC. The second thing is apply KCL except reference node. So there will be two KCL equations from A and C. So at node A, we can have a KCL. When you define the positive value as going to the node A, that means because IS is going to the node A, so this is positive plus IS, and I2 is defined going out from node A, so this is minus I2, and I1 is also defined, the direction is going out of the node A, so this is minus I1 is 0. So IS is I1 plus I2. What is I1? Is I1 VA minus VC plus I2 is R2 VA. And what is node B? Here, this is, excuse me, because node B is a reference, so node C. And I choose the going to the node is positive, so we define I1 is going to the C, so that is I1. And I3 is going out of node A, so this is minus I3 is 0. So I1 equal to I3. So what is I1? I1 here, VA minus VC, I1 equal VC I3. So we have two equations from the node. So because of that, there are two unknown variables. What is that? We are unknown variables, two node voltage V and VC, and we have two equations. So two unknowns, two variables, and two equations. So we can choose very simply. So if R1 is 1, R2 and R3 is 0.4, and IS is 4 ampere in textbook. Then you can insert the values here and there. And from here, you go 1, 2, 1 is 3VA minus 3C equal 4, and 2 is VA minus 3VC equal to 0. So based on that, VC is 1/2 volt and VA is 3/2 volt. You can simply express these every VC and VA. Then you can insert here. Then you can get the I1. We will show I2 and I3 and calculate VA and VC and here. So based on that, we can get all information about the voltage of all elements and current flowing through all element. That we can say we can analyze this electric circuit. That is a way how to use the node voltage equations. This is another example in your textbook. Equation is example 4-1. So problem is determine the voltage. Determine the value of the resistor here. This is R when you current flowing its way. So then we will redraw this circuit this way. This is the 4 ampere, and the resistor here, and resistor here, and there's some resistor here. This is the current source here. So in here, so this is 10 ohm. This is the 5 ohm. Then this is R. That's the question we have to. Then based on the voltage meter, they let us know the voltage here this is because this is a ground. So this is 5 volt. From ground to B, that means this is the 5 volt. Then we should determine R. That is the question. So what should we do? The solution is first, what should we do? We should define the element, the current at first. So I make the name of each current. I decide this is IS, because how many nodes there? This is one node, and this is node. This is also one node. So there are 3 nodes here, but one is the ground node. We call this a reference node. Then the remaining node is here and here. I decide the name of that is A and B. Then I make each element the voltage. What is node voltage here? Is VA. Node voltage VB. Then I'll define the current. I decide this is IS, and this current is I1, and this current, I decide the current direction here. This is I2, and I decide this current is I3, and I decide this current is I4. Then element current is a function of the node. So you choose the IS is, how much is it? It's a 4 because that is connected to the current source, the constant current source. Then, what is I1? I1 is current is flowing to this resistor. So voltage difference is of this resistor is VA. So there will be VA over the resistor is 10 because there is a 10. Then what is I2? R is a current flowing through this 5 ohm. So we should define this voltage here because there's VA and VB. So voltage difference between here is VA minus VB. So I2 will be VA minus VB and divided by resistance is 5. And I3 is, how much is it? Voltage difference here is 5 because VB is 5. So 5 divided by R. And there is 4 ampere in the problem. So I4, the direction we define, we decide the current, the direction of I4 is in this way here. So I4 will be minus 4 because 4 ampere is going through to this way. And from the problem, we know that because this is a 5 volt, so we know VB is the 5. Then next step is apply KCL. Then first node A, we have KCL. The current going to the node should be 0. So we decide going to the node is positive. So I is going out of the A, so minus IS. And I1 is going out from O, the A, so minus I1. And I2 also going out of node A, so this is I2. Should be 0. So we insert IS, I1, and I2 here. Then we can calculate IS minus 4 minus 10 VA minus 5 VA minus VB is 5, so it's 5 is 0. That is equation 1. Then node B, we have apply the KCL, the node equation. So I2 is going up, going to the B, so I2 plus I2, and I3 is going out, so minus I3, I4 is going out, so minus I4 is 0. And I2 is 5, VA minus 5. I3 is plus, minus R5. I4 is minus 4, so minus 4 is 0. This is equation 2. So we have two unknown variables. What is that? VA and R. And we have two equations. One node equation and two node equations. So we can solve R and VA simply. So from here, 3 VA minus 2 VB, minus 40 minus VA minus 2VA plus 10 is 0. So minus 3VA is 30. So VA is minus 10. We get it. And we get here, so 5 minus 10 minus 5 minus R5 plus 4 is 0. So there will be minus 3 minus R5 plus 4 is 0. So R5 is 1. So R is 5 ohm. That's a way. This is another example in your textbook. The example is for 2 and 2. And the question is obtain the node equation here. So and you need to check how many nodes are here, and you will get the node equation based on the figures. So we will do that first. Then as you see, when there are 4 nodes here, so here is a 1 node, right? Based on that, the R1 and that and this and this and this is connected through this node, and this is another node, and this is another node, and that is the last node. And problem gave us a ground point here, so we can choose this is a reference node. So then we can say there are 4 nodes. That means we can gather 4 minus 1 node voltage. That means we can get 4 minus 1 node equations. So what is the meaning of that? Then we have 4 minus 1 unknown variables. That means we have 4 minus 1 equations. So we have 3 unknown variables and 3 equations, and we can solve that problem here. So based on node voltage, we can calculate all the current in here. So to get the node equations, I will define the variables, especially current. So I decide this current is I1 here, and I will decide current is this current is I2. Oh, excuse me, there's some problem. I will change. That is not I1. This is IA. And I will decide this is not I2. This is IB. And I will change. This is not I3. This is IC. Because we'll be confused because I will use the same number of R1 and 5 in this way. So we choose this is I1. And I choose this I2, and I choose this current is I5, and I choose this current is I3, and we define this current is I4, and I will choose this current is I6. So then we are ready to use the KCL here. So here, the first, what should we do first? First, we should check the element current at first. We can choose I1. Okay. I1 is the current flowing through here is R1, but this point is VA, this point is VC based on here. So what is the voltage difference here? This is VA, this is VC, so voltage here is VA minus VC. So I1 will be, what will be down? VA minus VC and R2. Then what is I2? I2 is same things, because I2 is defined here this way, and this is VA and this is VC. So voltage difference is same thing, VA minus VC. So VA minus VC divided by resistor R2, because that is the Ohm's law. And what is I3? I3 is current from here. So voltage difference here and here is, this is VB and this is VC. So voltage difference is VB minus VC. So VB minus VC divided by R3. And what is I4? I4 is VB, and this is ground. So VB divided by R4. And what is I5? I5 is going from here to here. This is VA. This point is VB. So VA minus VB divided by R5. And I6 is current going this way, because this is VC and this is ground, so VC is divided by R6. That is a way how to make current. Then second thing is apply KCL, because there are 3 nodes, actually 4 nodes, but 1 node is a reference node, so we don't care about that. So we apply KCL to the other 3 nodes. So first, node A, here, what is that? I will choose, in this case, I will choose going out is a positive. So I1 is going out, then I can choose it. I will decide going out from the node is a positive, so I1 is going out from A, so I1 plus I1. And how about IA? It's going into there, so I decide in this problem, I choose the positive direction, then from node, so in the case minus IA, and I2 is going out. So what is that? Plus I2. And I5 is going out, so plus I5. And IB is going into the node, so minus IB is 0. Or we can choose another way, as I do before. I choose the direction is going into the node is positive. Then I can choose I1 in this case, because this is going out from the node. So I can choose is minus I1. And IA is going into the node, so plus IA. I2 is going out from node, so this is minus I2. And I5 going out from the node, so minus I5. IB going into the node, so plus IB will be 0. It's the same result. And then you can make equations. Now what is that? IA plus IB minus, what is I1? I1 is here. So alt VA minus VC minus I2 is here. L2 V. Oh, excuse me. This is something long. This is not 2. This is 1. Okay. I'm sorry. This is not 2. This is 1. That's the reason we should choose the exactly similar name of VC, and I5 is minus VA minus VB. L5 will be 0. That is a now first KCL node equation. And what's the node B? Node B, there are how many current? 1, 2, 3, 4, 5. So we can choose it. The first we choose here because IB is going out of the from B. So minus B. Minus IB. Then I5 is going into the B. So plus IB. And I3 is going out of B. So minus I3. Oh, excuse me, this is not B. This is 5. This is 5. This 5. 3. And I4 is going out of B. So this is minus I4. And IC is going into the B. So this is IC. So that will be 0. So minus IB plus I5 is VA minus VB L5. I3 is minus VB minus VC. I3 minus, oh, this is I4. I4 is VB divided by R4 plus IC is IC is 0. This is another equations, the node equation. Then C, node C here. There are 1, 2, 3, 4, 5 current here. So first, I1 is going into the C. So this is positive I1. And IA is going out of the C. So minus IA. I2 is going into the C. So plus I2. And I3 is going into the C. So plus I3. And I6 is going out of C. So this is minus I6 is 0. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I1 is R1 and VA minus VC minus IA plus I2 is out VA minus VC, and I3 is I3 VB minus VC minus I6 is I6 VC is 0. So there are 1, 2, 3. The 3, the voltage equation, and 3 node voltage equations. And we have 3 unknown values. What is that? VA, VB, and VC. If we get the other variable in system variables like current IA and IA and IC and IB and other variables R1, R2, L4, 3, 5, 6, then we have 3 unknown variables, 3 voltage equations, so we can get VA, VB, VC. So from the values, we can get that is things here. So this is the way how to make the node voltage here. It's very simple, it's not difficult, but it's very powerful tools. I mean, that give us how to make equations based on the unknown variables in the electric circuit. Next is a little different and things. I mean, that means there are different kind of source. It's current and voltage here. So for using KCL, the current of the voltage source needs to be determined, because I mean voltage source because when you use the current source here, then we can calculate. I mean, we don't need to calculate this current here, because this current gives us a value of the current following to this branch. So we don't need to calculate. This is very good things. If you have the current source when you solve the node equation, it's thank you. I know one variables without any calculation. It's a very good job. The problem is, if we have the voltage source, then you cannot calculate this current here. How calculate this current? This current does not define these values. It defines the other parameters in these other circuits. So we cannot get this branch current exactly. So you cannot get the current value of this current. So it's a quite complicated problem. Then how to solve that problems? That's the question. So in here, you can use the supernode concept. Supernode, what is supernode? I will explain about that, but supernode means the kind of the independent or dependent voltage source. I mean, you choose the node. I mean, as you see, the node here is like that. Then node A right here, and this is node B, and this is node 3. The 3 node, and this node is a reference node, so you can use the 2 node here, A and B. Then you cannot solve this problem because, okay, I will check it. I will give you an example. You can say this is a VA here, and this will be VB. That is from ground here. Then you can make a current here. This is I1, this is I2, this is I3, and this is I4. And you can choose this is because this is source. I will choose this is IS. Okay. Then what should we do first? First, what should we do? Element current. Okay, then I1 is this is VA here because it's ground. This is VA, so this is VA divided by R1. You can get it. And I2, what is that? This is R2, and voltage difference from here is VA minus VB because we choose the direction of current to is in here. And what is I3? I3 is current going to the I3, and this is VB. And what is I4? I4 is known because this is a source current source, V minus IS. Oh, I'm sorry, this is not IS. We should duplicate it, so this is I V, okay. Then, I mean, there are how many branch here? 1, 2, 3, 4, 5. But 1, 2, 3, 4, you can get it. The problem is, what is the IS? IV. I know the voltage here. That to calculate this current IV, we shouldn't know the impedance of between two terminals. But this is not impedance, this is a source. So the current IV does not define that values. Because the current over here is determined by the other electric circuits. So anyway, so if KCL, what is node A? Because IV minus I1 minus I2 should be 0. So IV minus R1 VA minus R2 VA minus VB is 0. And what's node B? Node B is here. Because I2 is going to the node B, so plus I2 minus I3 and minus I4 is 0. So IB is R2 VA minus VB minus I3 is R3 VB and minus I4 minus IS is 0. So to solve equations, because there are two equations, we can solve these equations when we have only two unknown variables. If we know the system, that means R1 and I3 and that values is known. Then unknown variable is VA, VB, and IV. So we have two equations, but unknown variable is VA, VB, and IV. Three variables. So we cannot get these solutions because we don't know the values. Then what should we do? This is a tip to make a KCL is using the supernode. A supernode is a kind of a here. So this is a simple way I will describe here. Is what is that? I only do that. First, I will do this again. First, we can make an element current. Oh. I will decide this is I1. It's same problems, but I will solve this equation in a little different way. Then, what is I1? We cannot know the IS. I will not define that current because we cannot choose. We cannot calculate this IS. So in this case, we will not calculate this current. I forget it. And I1 is the same problem. This is because this is node A, VA, this is node VB. So because it's ground, so I1 is VA minus 0 because it's 0 volt. Yes, I1 VA. And I2 is current from here. So I2 VA minus VB. And I3 is current here. I3 and VB. Then we will use KCL. Then we will do that, not here, because we cannot calculate the current this way. So first we'll use that here, node B. Then this is I2. This is out of node B, so minus IS3. And this is IS, plus IS will be 0. So from here, we insert the variables here, here, and here. Then I2 is R2 VA minus VB plus IS minus I3 is VB and R3. That will be 0. But here we have, even though we will not use node A, but here we have one simple hint here. What is that? Instead of using the node voltage A, but we get node VA is VS because that is connected in this way here. So why we use the node equation? Because we have n-CL node voltage, and so together this n minus node voltage we make n-1 KCL equations. Why? To solve the n-1 node voltage here. But in this case, we cannot get the KCL based on this node A. But why we cannot make a KCL equation? Because of we cannot define this current. Why? This current is going to the voltage source. But instead of that, even though we cannot get a KCL equation based on node A, why we make a node A equation? Because we want to know the voltage VA. But this voltage source also give me a hint. What's the value of VA? That is VS, same thing. Wow, thank you. This is good things. We should know about VA, but already you let me know VS. So we does not need to make a KCL based on the node A anymore, because voltage source give me a solution of node voltage here. So we don't need to make a KCL node A. Instead of that, here in node equation B, we insert VA is V, how much? VS in this way. So that is R1 VS. This is R2 VS minus VB plus IS plus R3 VB equals 0. I mean, that is your system parameters, and we already know the unknown is VB. One equations, one unknown variables, so we can get a VS. So voltage source is connected to the reference node here. Then, thank you. We don't need to make a KCL at this node because we already know the node voltage VA. The one of node voltage is the voltage values of voltage source. There's a way to calculate that. Okay? Then this is another example. This is the way we have to use the supernode. So there's this case, the voltage source is not connected to the reference node. There is a little complicated problem here, but I will give you that things. So in this case, the VS is connected in this way. I mean, the point is not ground. I mean, there are how many nodes there? This is node 1 and node 2 and second and the third node. There are 3 node system. And we choose that ground is a reference node here. So then the remaining node is A and this is B. And node A and B is connected by the voltage source Vs. So in this case, we choose the supernode. The supernode means it consists of two nodes connected by the independent or dependent voltage source. So we define that is a supernode. So instead of two nodes, we make a one supernode. Why? The reason is simple. We can calculate the current going through this voltage source, this current. We can calculate it here. Because that current is calculate not only this voltage but also the other component out of the circuit. So we choose there's a supernode. Then it's okay. Supernode is a node. Yes. I will give you some example. This is node. This is a path branches. The current here, I1, I2, I3, I4, I5, I6. What is a KCL? KCL means I1 plus I2 plus I6 is 0. Right? Then we make two node here. This is I1, I2, and I3. And this node is I4, I5. And this current going out of here, going there. Then we can get the KCL here. What is that? I1 plus I2 and minus I3 is 0. This is the KCL. It's okay? That's okay. And based on that, why is a KCL? Because this is I3 plus I4 plus I5 equal to 0. Then we can add in two equations. I3, I4, I5 0, and adding here, what is that? I1 plus, I2 plus, I4 plus, I5 is 0. What is the meaning of that? Even though we make this is a kind of a big supernode, the current going into this supernode, then sum of them should be 0. This is a KCL. So this is the same things. Even though we define here this, then all branch current going into this supernode, the sum of this branch current should be 0 because of KCL. Then we don't need to calculate what is the value of this current between two nodes. We don't care about that because our concern is only current going into the branches into the supernode. So in this example here, we can make then we can make element current. First, I will define the current here. Define this I1, this is I2, and this is I3. And we make a node voltage. This is VA, and this is the VB. Then what is current? I1 will be VA divided by R1, and I2 will be VB divided by R2, and I3 will be minus IS. And second, KCL and every node. because this is ground node, I mean this reference node, so there only remain only super node. As super node, question is I1 is out of here, so minus I1, I2 is out of here, minus I2, and I3 is out of here, minus I3 will be 0. So we can make here minus, that will be I1 plus I2 plus I3 will be 0. I1 is R1 VA plus R2 VB and minus IS will be 0. How many unknown variables are there? There are two unknown variables, VA and VB. But we have only one equation, so we cannot solve this equation because we need more equations. Here, based on supernode, we can get one more equation. What is that? The relation between node voltage here. What is that? Because it is Vs, so VA is VB plus Vs. Vs plus VB. So VA equal Vs plus VB. This equation from the node supernode. So how many variables? VA, VB, and how many equations? We have two equations. So we can solve it. Two variables, two equations. We can get the variables. That's the way how to use the supernode.